the physics CET paper dated 15th July 2023. Start with first question. What is the first question? The temperature at which centigrade and Fahrenheit scale gives the same reading, correct? So we know this formula. Is Tf is equal to Tf is equal to 9/5 Tc plus 32. So now they are telling both the readings should be same reading value. So I will put Tf is equal to Tc. Tf is equal to Tc if you put 9/5 Tc plus 32. So you solve this for Tc, you get it as minus 40 degree. This is option. Then temperature of constant volume gas thermometer. Okay. This much. If it's reading at an unknown temperature is 100 centimeter, and the temperature is. So we know alpha is equal to delta L by L delta T. So alpha will be constant in first case and second case. Hai? So alpha, if you see, alpha will be equal to, I will take delta L in these two cases. So 60 minus 40 is 20 divided by initial is 40 into delta T is 100 minus 0. It is 100 is equal to, this is also equal to this temperature and means this volume, this L and this L I will take. So delta L will be 100 minus 40, that is 60 divided by initial length is 40 into delta T. Delta T is T minus 0. So T they are asking. So you consider this and get T. So if you solve it, what will you get? 40 will cancel and 1s are 3s are, T will become 300. Then two uniform, third question. Then two uniform brass rods A and B of lengths L and 2L, radii 2R and R respectively are heated to the same temperature. The ratio of increase in the volumes of A to that of B is. So if you see, they are asking delta V 1 divided by delta VA divided by delta VB, right? So now these are brass rods. So gamma is equal to delta V by V, correct? So both are brass rods only, gamma will be same. So delta V is proportional to V. It means delta VA by delta VB is nothing but VA by VB. And we know what is VA by VB. VA by VB is VA is, see, this is radii and length they have given, so it is cylindrical actually. So volume will be pi r square L. So pi RA square LA divided by pi RB square LB. So pi cancel. Now if you see, RA is 2R. So 2R whole square is 4R square, and length of A is L, and RB is R square, LB is 2L. So 2L. So R square is 2L. So 2 is to 1. Option C. Then we go for fourth question. What is fourth question? A bimetallic strip consists of metals X and Y. It is mounted at the base as shown. Mounted rigidly on its base as shown. The metal X has a higher coefficient of expansion compared to that of metal for metal Y. Okay. The bimetallic strip is placed in a cold bath. So when you keep it in a cold bath, they'll get compressed, na? Because cold bath temperature reduces. If you keep it in cold bath, its temperature reduces, so it will compress. It will not elongate. So now if you see which will compress the more, X has higher coefficient of expansion. So suppose gamma is equal to delta V by V delta T, or alpha is equal to delta L by L delta T. So if this is more, for same delta T and same length, initial length is same for both, right? Delta L will be more for X. So X will have more delta L, and here delta L is compression, means it will compress. So X will compress the more and Y will compress the least. But these are rigidly connected here. So uh, X will not become like this. This is supposed to become like this, and but because this is fixed, this will remain here only, and this will also remain here only. So what will happen? X will compress the more like this, and this will compress the least. So while coming, it will pull this also. So the system will bend towards left. Understood? It will become like this. So here if you see its length is more compared to its length. It means it has compressed less, it has compressed more. Then fifth question will go. The coefficient of volume expansion of a liquid is 49 into 10 power minus 5 Kelvin. Calculate the fractional change in its density when the temperature is raised by 30 degrees Celsius. Okay. See, gamma is equal to delta V by V delta T. Delta is density is equal to mass by volume, and here delta V by V value, if you see, gamma is 49 into 10 power minus 5 and delta T is 30. So 30 into this, if you do, what will get? It will be very less value. Hai na? If you take it as 50 also, it will become 1500 and 1.5 into 1500, then 15 into 10 power minus 3, which is very small value. So if it is very small value, delta rho by rho can be written as delta V by V. So then delta rho by rho becomes gamma delta T, correct? Delta V by V is gamma delta T, right? Gamma delta T. So your answer is gamma delta T, which is 49 into 10 power minus 5 into delta T is 30. Whether it is delta T, so degree Celsius, degree Kelvin will not matter. Sorry, Kelvin will not matter. Degree Celsius or Kelvin, that doesn't matter. So this, if I take this as 50, this 1500 into 10 power minus 5. If you solve, you will get 1.5 into 10 power minus 2. Right? Otherwise, what you would have done? Fractional change in volume density means rho 2 minus rho 1 by rho 1, which is rho 2 by rho 1 minus 1. Now density is equal to mass by volume. So here also mass by volume, here also mass by volume. Volume will not change if you raise temperature. So it will become m by v2 by m by v1 minus 1. It will become v1 by v2 minus 1. So here we will get delta v by v. Delta v by v will be gamma delta t. Delta v by v will be gamma delta t. But delta v by v is v2 minus v1 by v1, which is v2 by v1 minus 1. So v2 by v1 will get here gamma delta t plus 1. You'll get a value v2 by v1. But this is v1 by v2. So 1 by that value minus 1 you do, they will get delta rho by rho. But this will also work. Delta rho by rho is equal to delta m by m plus delta v by v. Delta m by m is 0. Then sixth problem, an iron bar of length 10 meters is heated from 0 degrees Celsius to 100 degrees Celsius. The coefficient of linear thermal expansion of iron is this much. The increase in the length of the bar is. So delta L is equal to L alpha delta T. L is given, alpha is given, delta T is given. So this into this into this. What will you get? This 10 power minus 5 into 10. So it is 10 power minus 5 alpha. L is 10, 10 power minus 4. 10 power minus 5 into 10 is 10 power minus 4 into delta T is 100. 10 power minus 4 into 100 is 10 power. 10 power minus 4 into 100 is 10 power minus 2. and all are in SI units, so metal. So this is 1 centimeter, right? Understood? Basically, I told alpha is equal to delta L by L delta T. So delta L is equal to L alpha delta T. Understood? Delta L is L alpha delta T. It was for 7th question. Which one of the figure gives the temperature dependence of density of water correctly? So as temperature increases, it expands actually. So volume increases, so density should decrease as temperature increases. So there is a general case. There is a general case. So for water, as temperature increases, density should reduce. So this will not be the answer because temperature is increasing, density is also increasing. This will also not be the answer, constant. Between these two, if you see. For water, we know anomalous behavior of water. At 4 degrees Celsius, it will be maximum. After that, it increases, but before this, it decreases. The anomalous behavior. Then we have 8th problem. So two rods, one of aluminum and the other made of steel, have initial length L1 and L2 are connected together to form single rod. Okay. And we said the question of linear expansion of aluminum steel are this much. Therefore, length of each rod increases by same amount and the temperature. Find the ratio. Okay. So we know alpha is equal to delta L by L delta T, correct? So now for first rod, alpha A is equal to delta L divided by L1 delta T. And for second rod, alpha steel, right? Alpha S is equal to delta L by L2 delta T. Its length was L2 originally. Delta L is same. By same amount, length increases. Delta L is same. Temperature is raised by T degrees Celsius. So delta T is also same. So now they're asking ratio of L1 by L1 plus L2. So if you take delta L by delta T as some constant, what will you get? K by L1 suppose. So here also it will be K by L2 because delta L and delta T are same here also. So now L1 will be K by alpha A, है ना? So L1 by L1 plus L2 will be K by alpha 1 divided by K by alpha 2 minus plus K by alpha 1. है? So if you solve, what will get? Alpha 1 plus alpha 2 divided by alpha 1 alpha 2 alpha 1 alpha 1 cancels. Alpha 2 by alpha 1 plus alpha 2. Oh, alpha 2 means see L2 alpha 2 I2. So it is steel actually. So alpha S by alpha A plus alpha S. So option C. The ninth problem, two solid spheres of same material have the same radius, but one is hollow while the other is solid. Both spheres are heated to same temperature. Then you see alpha is equal to delta R by R delta T. So the linear dimension is radius here. So alpha is same for both material is same. Delta T is also same. Then radius will increase the same amount. So whether it is hollow or solid sphere, it will have same expansion. But one thing is, if they mention there is some liquid inside the hollow sphere, inside the hollow is a solid sphere suppose, and inside the hollow sphere there is some liquid suppose. So when you change the temperature, when you heat it, what will happen? Because of its own material, it will expand to same amount, but this liquid will also expand, and liquid will expand more, or air is there, it will expand more. If it expands more, then pressure increases. So then it may apply some pressure here, and due to that pressure also there may be some increase in volume. Okay. Then hollow sphere will expand more. But because nothing is given, expansion will be same for both. Okay. Then we'll go for 10th question. The apparent coefficient of expansion of a liquid when heated in a copper vessel is C, and when heated in a silver vessel is S. If A is linear coefficient of expansion, but this is volume coefficient of expansion. And the linear coefficient of silver is. So what is this apparent? This concept has been not taught, right? So if you see, well, if you think you'll get, but I will explain you. Suppose water is there in this container, ठीक है, vessel. So now suppose the water is still here, and suppose this is a vessel. So now when you heat it, what will happen? This is initial level of the water. Suppose 1. So it will go from here. Suppose you heated it and it went from here to here, 1 to 2. Okay. But actually what is happening when you heat na, this vessel will also expand. And suppose the vessel expanded this much. And- But you are saying it went from here to here. Hai na? You are saying it went from 1 to 2. Actually when it went from 1 to 2, uh, you are feeling that only this much is the expansion which has happened in the liquid, which is apparent expansion or apparent delta V, you can tell. This is apparent delta V. But actually, delta V is how much? Really, how much is the delta V? Liquid has how much it has went? Liquid has went from here to here, and liquid, because this vessel has increased its volume, this liquid which was contained in this much volume only, it will it will go na everywhere. It will fill up this space. Correct? It will fill up the space. Understood? It will fill up the space. If it fills up the space, actually delta V is how much? Initially it had this much volume only, but now how much volume it has? It has this much volume now, right? It has this much volume. So really delta V is how much? Real delta V is how much? Real delta V is this much. And it is this much. Real delta V is this minus this, right? So you see real delta V is this much expansion has happened, that is apparent, plus how much ever the vessel has changed its volume, right? So vessel's change in volume is this much. So that much also in real volume change, real change in volume. It gets, this will also come in real change in volume, plus this apparent one, right? That will be the real expansion which water has taken, which liquid has expanded to. That is the real volume to which it has expanded to. And so delta VR is equal to delta VA plus delta VV. So now this is the case. Then initial volume of vessel and initial volume of water is same only, right? Like this when it was. Volume of water is this, liquid is this much, volume of vessel is also this much only. So if I do delta V by V delta T divide everywhere by V delta T, V is same for both all the people, means all the things here, initial volume, and delta T is also same. So that is okay then. So delta V by V delta T, this will be gamma real, real coefficient of expansion, and this will be apparent coefficient of expansion, plus this will be coefficient of expansion of the vessel. So this you should know. This is the concept. So now if you apply for this situation, this question, copper vessel is C. When heated in copper vessel, apparent coefficient of expansion is C. So that is apparent, right? So this is C plus gamma V. Gamma V vessel, copper vessel. So copper vessel, this is linear coefficient of expansion. That is alpha. That is alpha of copper. Alpha of copper is A. So gamma of copper will be 3 alpha. 3 alpha C. That is 3A. So this will be 3A, which is equal to gamma R. Now gamma R is also equal to, you take now steel vessel. And steel vessel apparent coefficient is yes plus linear coefficient. Okay, they are asking that only. So 3 alpha of steel, right? Now they want alpha of steel. So what you can do is gamma R and gamma R are same. So equate these two equations. C plus 3a is equal to S plus 3 alpha S. So C plus 3a minus S divided by 3 is alpha S. C plus 3a minus S divided by 3. Option B. Okay. Moving for the next question. So what is the next question? 11th horizontal range was projected. Okay, all these are kinematic. Okay, these are kinematics. So we'll stop it here. So if you have any questions, you can ask later.